So, the Centre for High Carbon Capture Cropping, also known as CHCX3 for short, is a 4-year, £5.9 million multi-partner research project, which spans agriculture, industry and academia, and led by Niab, my colleague, Dr. Lydia Smith. So our aims are to help UK farmers, growers capture more carbon and build farm resilience through basically diversifying their cropping. We aim to help with the insetting and offsetting of greenhouse gas emissions and to offer new revenue opportunities in the carbon market. And very importantly, and certainly in the context of today's presentations, we aim to support enhanced value chains for industries such as textiles and construction that are using biorenewables. So a little bit more about our objectives. So we're looking to evaluate a range of food, feed and industrial cropping options, more about those in a moment, that have the potential to enhance atmospheric carbon capture and sequestration both in the soil and in crop-based products. Again, very relevant to today's webinar. We're looking to quantify carbon removals consistent with emerging standards for measurement, monitoring, reporting, and verification, and to develop a platform for tracking, not trading, soil carbon, but to assist, therefore, with the insetting or offsetting of emissions to enable new revenue opportunities and to support corporate sustainability goals. We're looking to help optimize production of renewable biomaterials for fiber, textiles and construction, and to help build value chains. Again, very relevant to today's webinar. And finally, to establish a UK knowledge hub that provides some resources, information to support the effective uptake of crops with high carbon capture potential. So a bit more about our cropping options. So the research itself is focused on the economic and environmental potential of 4 main cropping options and their associated tillage systems, so how we grow them essentially. So we have rotational cover crops. They may be grown over the winter or in the spring and summer. Annual fiber crops, focusing in this case on industrial hemp and flax, and we'll hear about those a bit later. Perennial food, feed and forage cropping options. That includes cereals. Obviously, perennial cereals are not much of a feature at the moment in the UK, but certainly herbal maize are gaining traction. And finally, perennial biomass crops. And in this project, we're focusing largely on miscanthus and willow, and to a limited extent poplar, but obviously in the context of Paludiculture, there are others that consider like typha, and I'm sure we'll hear more about those later as well. So we have a very diverse partnership, which spans academic and research organizations, companies that are involved in developing crop varieties for the crops that we're interested in and developing those crops in terms of in the field, our partners in the sort of construction and in those value chains, and also companies that have and organizations that have a strong sort of knowledge exchange role so that we can hopefully get the message out there. If you'd like to know more about the centre, you can contact us. We have an email address, chcx3@niab.com. There's a QR code there, which hopefully if you scan should take you to more information, or our website, which is www.carboncapturecropping.com, where you can sign up for our free e-newsletter and more events like today. So the project CHCX3 is funded by DEFRA under the Farming Futures R&D Fund, Climate Smart Farming, and it forms part of DEFRA's Farming Innovation Programme delivered in partnership with Innovate UK. Right, I'm going to stop sharing my screen now, and I am going to take the opportunity to introduce Jim Milner of Natural England. And Jim, hopefully, will give us a quick introduction about the Paludiculture Exploration Fund. Over to you, Jim.
Cheers. Thank you, Stuart. I'll share my screen, which is that one, and start my presentation. So hopefully you can see that. Yeah, I'm getting a thumbs up. Great. As Stuart said, Jim Milner, and working for Natural England, and I wanted to, well, as Liz said earlier, this is either I'm to blame or I'm going to take the glory for this webinar. So I sat in on a high carbon capture webinar. I think it focused on hemp, and I was struck by the parallels with some of the exploration we're doing in the Paludiculture Exploration Fund which is focused on the more fibrous crops and how they can be potentially used in the construction industry. And that concept of, you know, not wanting to move fibrous crops very far from where they need to be processing. So I thought there's some synergies here going forward. But a little bit more about my project and paludiculture. I mean, it's a new word to some, perhaps not. Looking at the introductions on the chat, maybe not all of you. But this slide, there's 3 pictures there, and I put them on there really to describe different elements, I guess, of paludiculture. Paludiculture is very simply farming on wet soils, and for our focus, it's wet peat soils. If the peat is wet, we keep the carbon locked up, as many of you will understand. So on the left there, we've got a carbon farm. So that's essentially Blank's Wildlife Trust trying to grow sphagnum as a carbon crop. So it's kind of stretching the definition of crop, I guess, because it won't be taken off. It's simply just accumulating carbon. So that's a kind of semi-natural or natural habitat that's being used there for carbon capture. In the middle, we've got a field in Norfolk on peat. That's growing solid veg. And the landowner there has raised the water levels to essentially the land drains, so 60 centimeters below the surface. Now that might stretch the definition of paludiculture a little bit, but it is re-wetting the peat, and that's essentially what we're aiming to do. And then on the right there, we've got a picture of some typha being grown in as a trial crop, and that's what we typically think of, or what I typically think of when I think of paludiculture. And it's basically raising the water level to within 10 centimeters of the surface, and growing a crop on that wet soil. The 10 centimeters, why is that relevant? That's seen as the kind of sweet spot in greenhouse gas management. So if we go above 10 centimeters and have completely waterlogged soil with water standing on the surface, we get a significant increase in methane, which you'll understand is a very damaging greenhouse gas. So that 10 centimeters keeps the methane in a balance where we're still having positive effects. Just a little bit of, I mean, the word paludiculture was developed by colleagues in Europe at the Griesfeld Myers Center, simply wet agriculture, plos for swamp, culture for agriculture. How it forms, and it's kind of getting embedded in a small way into policy now. Many of you will have come across the Lowland Agricultural Peat Task Force, which was a action in the England Peat Action Plan. And Robert Cordwell, the chair of that task force, wrote a report recently, or well, last year now. And recommendation 14 essentially recommends that we adopt a commercially viable paludiculture. And that was fully endorsed by the ministers at the time, which, yes, there may be changes afoot soon. Who knows? I just want to put this in. I use this slide in a lot of my presentations, basically to sort of to place paludiculture in a kind of a continuum between sort of dry, perhaps wasting peat soils, and that continuum would end in fully restored habitat or intact habitat. Now, paludiculture, as I mentioned at the start there, is seen as this kind of 10 centimeters below the surface water management, water table management. But I think we can all see how in a landscape that will be will be achievable in some places, but not so achievable in others, and there'll be a fluctuation in water levels and what's achievable and the opportunities in that landscape. So this slide hopefully explains that, I think paludiculture has a place in that kind of wet soil sort of re-wetting part of the peat mass, as they're doing in Norfolk in that first slide I showed, right through to restoration. And if we think of something like a reed bed where we're growing reed for thatch, that's paludiculture, but it's also a really valuable habitat as well. So a little bit about the fund that I'm managing. So we've got an engagement, it's in two parts essentially. So we've got the engagement contract with Liz, who's on the call, is ably managing for us, and with Niab. That's there to encourage discussion. Paludiculture is at a very, very early stage. Earlier there, you saw the recommendation, which was a 10-year ambition. We're probably in maybe the second year of that ambition. And globally, paludiculture is at the very early stage. So the engagement contract that Niab are managing helps us to develop the community of interest around paludiculture. It helps us start to share that knowledge and encourage discussion, and really respond to that community to respond to developing issues such as this one, or opportunities such as this one. And we also had a grant offer. So we had 5 million over 2 years. We're halfway through that. So we're just into our second year. We've got 12 projects that are exploring different aspects of paludiculture that cover the whole kind of value chain, from understanding how to sow or plant the crop, right through to the products that we might have from paludicultural crops. And this slide here, really, it focuses on one of our projects, so Fibre Broads in the Norfolk Broads. And I picked on this particular project because it really, one, it shows the breadth of what we're trying to achieve with the Paludiculture Exploration Fund, but also this particular project is focusing on the fibre as well, which is something I think both of our projects have in common. So with the Fibre Broads project, they're kind of looking at the actual growing of the crop. So they've got a trial at Horsey where they're growing Typha, which I think the main objective for that trial was to improve water quality, which is a side benefit of paludiculture. I think the potential of something like Typha or bulrush to export nutrients from the hydrological system is pretty well. It's well understood, and I think paludiculture adds another aspect to that. They're also looking at spatial planning. So they've done a lot of work prior to being involved in this project around mapping the peat in their area, and also mapping where the water is, what the levels are, and how that changes over the year. And then they're also taking that forward to work with farmers in the region. So they're working with Norfolk FWAG to really promote discussion and engage farmers in the possibilities that I think climate change is probably forcing some of these conversations as well. So it's of the moment, I guess. And then finally, and perhaps the most exciting bit for everyone on this call is they're working with with Norwich University Architectural Department, and they're hoping to build a demonstration building, a small house, if you will, built from paludiculture products. So that kind of project really illustrates what we're trying to do with PEF. And I'll leave. This is my final bit of promotion for the project. So this is a website which I can take little credit for. Liz created this for us. And this is the kind of hub of our community, if you like. So on there you can see we brought the events that we're setting up, projects and any other resources that we're building up around Paludiculture. Again, we've got the ubiquitous QR code, so you can take a screenshot of that, or do get in touch with me. So yeah, I shall leave it there. I've probably used more of my time than I had. But if there's any questions, do put them in the chat or get in touch. Shall I stop sharing now?
Yes, please, Jim. Good. Right. Thank you very much, Jim, for introducing the project and also a little bit more about Paludiculture. And as you say, there are lots of synergies between the work we're doing. I think for me the positive thing is that between us, I think we can offer sort of options for improving carbon capture on a whole range of different crops, different farming types, different geographies, different soil types. And that's really what we're all about. Yeah, and I'll just add to what Jim said. If you can put questions for the speakers into the chat, that would be fantastic. And if you have joined us a little bit late, introduce yourself, if possible, into the meeting on the chat. Right, so on to our first of our main sort of speakers now. And so I'm delighted to welcome Dr. Mike Lawrence, who's Director of Research at Natural Building Systems. Natural Building Systems are one of our partners within the CHCX3 project. And Mike's talk is about market demand for biorenewables, for biomaterials rather, in construction. So if you'd like to unmute yourself, Mike, and share your screen.
Hi, yes, I'll just share my screen. Hopefully that works. Can you see my slideshow?
Indeed, we can.
Good.
Yep.
Okay, so I'll try and whiz through this and catch up time because we're running a little bit late, but I just want to set things in context. Construction is responsible for an enormous amount of emissions, and this is the main driver behind our own business, Natural Building Systems, where we're trying to develop construction systems which are less environmentally impactful. So of the total amount of emissions globally, construction is responsible for over a quarter. And the embodied energy of the materials in in buildings is 10% of global emissions. So it's a very, very significant element. Just to talk you through something about the life cycle of a building, first thing we do is we design the building and we try and work out what materials to use. So if we use low embodied energy materials, we are already contributing to the reduction in the environmental impact of buildings. We've then got to make the building out of these materials, and the best way of reducing impacts there is using efficient construction systems such as prefabrication, minimizing waste, trying to have supply chains which don't involve too much distribution distances, because obviously that increases the environmental impact. And then the major part of the building, 100 years worth of the building, is the energy that it uses. And that energy is partly in heating it and lighting it and using energy generally to occupy the building. So one tries to design a building which minimizes all of that use. And part of that is when you're over the lifespan of a building, maybe 100 years, you will have occasion to change the use of the building. So, and that might involve reconfiguring the building. So anything that we can do to reduce the impact of such a reconfiguration is well worth doing. And then at the end of life, the building will get demolished. And potentially, if we can use the elements of that building to make a new building, rather than just destroying the elements, that is part of the circular economy. And that is, again, a driver that we have in our own business so that we design buildings which can be taken apart and re-put together again at end of life to make a new building, which again reduces the environmental impact of that building. If we talk about natural building materials, they are all sustainable, and many of them are renewable. So plant-based materials, animal-based materials, you grow them, you use them, and then you regrow more. And many sequester atmospheric carbon dioxide, which I'll talk a little bit more about in a second. And many are recyclable, so you don't. They have a use at end of life. You can reuse them either for the same purpose or for another purpose. So opportunities for natural materials in modern construction, that one of the most significant things is the reduced greenhouse gas emissions, because again, we're growing things, we're taking carbon dioxide out of the atmosphere while we grow them, which reduces the embodied carbon. And because of the nature of natural building materials, they tend to offer a better environmental performance in the building itself. And again, I'll talk to that in a moment. A part of that is healthier buildings. With regard to the materials themselves, they tend to have inbuilt resource efficiency because they're renewable. You can also minimize the waste of the buildings because they tend to be grown locally to where they're being used. There is a security of supply. And the concept of short cycle crops is very important because if you think of timber, it takes maybe a minimum of 15 years before you can use it. So it's sitting there absorbing carbon dioxide for 15 years. You chop it down and start using it, plant some more, and it takes 15 years to grow. So it takes quite a long cycle to reuse it. If you can use an annual crop, you can plant it, grow it, use it, plant it, grow it, use it every year. And that improves the carbon efficiency of the material. So short cycle crops are very interesting, and where we can use those as an alternative to timber, it creates quite a benefit. And obviously, all of this requires farmers to grow. So it creates new markets within agriculture. The significance of embodied carbon, I told you at the beginning about the fact that construction is responsible for 10%, or the materials involved in construction are responsible for 10% of global emissions. Cement, for example, contributes around 5% of global emissions. Where we can use bio-based materials, we can start to take that away. So hemp lime, which is a mixture of hemp shiv with a lime or a cementitious binder to make a building material, actually stores carbon for the lifetime of the building. Straw bale stores even more because you don't use the binder. Masonry, like bricks and concrete blocks, actually emit twice as much as hemp lime stores. So it's the more you can substitute traditional construction methods for bio-based construction methods, the more impact you can have on the reduction of carbon. Just a very brief, and I'm sure this is sort of something that maybe you're all familiar with, but just to talk to you through biogenic carbon. It's produced through the action of photosynthesis. Plants use the energy from the sun, the carbon dioxide in the atmosphere, and converts it chemically into the plant itself. It stores the carbon in the plant and gives off oxygen as part of that chemical process. So it's actually feeding us with stuff that we breathe and the water that comes off, or the water is absorbed in the plant to be part of this chemical process. And that carbon which is stored is what we call biogenic carbon. Just as an example, so you can understand how much carbon dioxide is absorbed when we create a kilogram of carbon in a plant material. Well, if you use a bit of basic science, molecular weights of carbon and oxygen, so carbon dioxide has a molecular mass of 44. Carbon itself is 12. So if you take one over the other, basically for every kilogram of carbon that you are creating, you have taken away 3 2/3 kilograms of carbon dioxide from the atmosphere. So it's a very efficient way of taking carbon dioxide out of the atmosphere. And most plant materials, about half of a plant material consists of carbon. So this is from a recent publication showing you the share of carbon in particular materials and how much the equivalent carbon dioxide is. So hemp, for example, just under 50% of hemp consists of carbon, and it's taking 1.79 kilograms of carbon dioxide out of the atmosphere for every kilogram of hemp. And for paludiculture, very similar. Reed taking 1.76 kilograms of carbon dioxide out of the air for every kilogram of reed. So it's a very efficient way of taking the carbon out of the atmosphere. And if you use those materials and fix them into a building for an extended period of time, over that whole period of time, that carbon dioxide has been taken away from the atmosphere. I mentioned about building health before. One of the interesting things about bio-based materials is their ability to adsorb and desorb humidity, and also to manage the transfer of heat through the system. Humidity is a big issue in buildings. If it's too high or if it's too low, it creates an atmosphere which is not very nice for people. If you have too much humidity, you get molds, you get high microbial levels, and all of that affects the health of the occupants of the building. And this is well-known concept, and it is referred to as sick building syndrome. So people who go into poorly ventilated buildings or buildings which are sealed, either too dry or too moist, they get headaches, breathing difficulties, skin problems, all linked to the sorts of materials which are held within the building if it is not managed properly. Hence why you tend to have a lot of air conditioning around. So the bio-based materials in the buildings act as a sort of natural air conditioning. So that reduces the cost, the energy cost of managing that building. So if you use bio-based materials, you end up with a much more stable environment inside the building. It tends to float between about 50 and 60% relative humidity. And the other thing is the way in which some materials work. Hemp is a particularly interesting one. It slows the passage of heat through the building, which means that if you get the thickness right, you can effectively maintain a very stable level of heat inside the building whilst it's going up and down outside. This is quite a well-known graph showing the impact of either too dry or too wet environments in a building. The drier it is, the more ozone you get, for example, the more moist it is, the more viruses and bacteria are able to live. And there's this sweet spot between about 40% and 60% relative humidity where it doesn't really support the sorts of organisms and materials which are bad for your health. And that is why using bio-based materials such as hemp gives you this sweet spot without you even having to try, without you having to put air conditioning through the system or whatever.
We are Natural Building
This is a
Systems,
little
multidisciplinary team
video
of
I'd like you
architects,
to watch.
engineers, material scientists, and construction professionals, united in our passion to build sustainable, affordable, and healthy buildings. I'd like to introduce you to Adept, a new kind of modular construction solution. Its demountable components allow non-destructive alterations and disassembly. Its unique hemp biocomposite captures enough CO2 to ensure that our buildings will be carbon negative in construction, as well as carbon neutral in use. In other words, new homes and workplaces needn't be part of the problem, when they could actually be locking away carbon as part of the solution to climate change. Our breathable panels are made from natural materials, harnessing their hygrothermal capacity to regulate temperature, humidity, and improve air quality. We are combining these properties with new technology to perfect our products, which are due to launch in 2022.
So we did launch in 2022, and we have buildings out there now. There are 10 or 15 buildings that are already in existence, and we're building maybe one a month at the moment. Part of the design for the building is a use of an alternative binder to make hemp more practical in terms of its construction. So I've developed an alternative binder to lime, which has a more rapid set. You don't need to put water into the system. One of the problems with hemp lime is the more water you have in the system, which you need in order for the lime to set, you end up with all this surplus water, which you've got to take out. And whilst the water's in the system, thermal conductivity is not as good. And also it is a vector for mold growth. So not having the water makes life a lot easier. It has a lower carbon footprint, and the composite has a lower thermal conductivity. It creates a product that we call HempSil, which can be fabricated at different densities. It can be made as a lightweight insulation. It can be made as a block. It can be made as a board, such as the image here. Low thermal conductivity is lower than hemp lime. Lower density, which means it's lighter, easier to handle. Compressive strength is not terrific, but it doesn't need to be terrific for insulation or non-load bearing materials. So in many ways, it's good because the lower compressive strength implies lower density, and lower density implies lower thermal conductivity. And it is also really good at moisture buffering. So when you've got excess moisture in a room, it will absorb it. When there's too little moisture, it will give it out, and it will maintain this really nice 50 to 60% relative humidity in the building. We are also working on alternative materials, different binders. So not just the HempSil binder, but I'm also working on geopolymer binders and a bio-based thermosetting binders. So this image on the right here is of a hemp made with a bio-based thermosetting binder using the waste stream from biodiesel. And we're looking at alternative aggregates. So I'm trying to develop an alternative to wood wool using miscanthus and willow. I'm looking at flax, looking at hemp straw, so longer strands of hemp straw, to make different kinds of materials which are all going to be applicable in various different aspects of of construction. Our construction system is designed to encompass everything. So it will do the walls, the floors, internal walls. It's designed to be cost competitive with traditional methods. It's much, much quicker to build. It's adaptable, it's breathable, energy efficient. It's future-proof because you can disassemble bits and put them back again in a different order if you want to. And then at end of life, you can disassemble the whole thing and put it back together again in a different configuration. So just to show you the environmental impact here. So a traditional brick building per square meter of wall emits over 200 kilograms of carbon dioxide. Whereas one of our system buildings actually takes over 50 kilograms of carbon dioxide away from the atmosphere. So every house that we displace is going to take, from traditional build, is going to take well over 50 tons of carbon dioxide out of the atmosphere. And this was an announcement yesterday from Angela Rayner saying that they want to build 1.5 million new homes over the next 5 years. That's 300,000 homes. We are in the position to be able to contribute to that delivery for low-cost buildings, using local sourced materials, and the ability really to contribute in a major way with through the whole value chain, from the farmers all the way through to the construction industry. Sorry, I hope I didn't take too long. Maybe questions for after the end of the presentations.
Thank you very much, Mike. No, that was actually perfect. You got us spot on time. So we do have a moment or two now for some questions. I'm just looking to Jasmine to see if there are any in the chat for Mike or for Jim's earlier presentation.
Hi, Stuart. Yeah, I have one from Chris. And he said that he understands that lime products absorb CO2 when deployed in buildings and over years of curing. But what is the story in the original production of the lime mortars in the first place?
Okay, so to make lime, you basically take limestone, or depending on the kind of lime, if you want to make a lime which is hydraulic lime, you will take limestone with a bit of clay in it. You'll crush it up, which uses energy. You will then burn it in a kiln at between about 850 and 1,000 degrees, depending on the clays involved or whatever. You will then, having burnt it, what happens there is you're using energy to burn it, and you're driving off the embodied carbon dioxide, which is in the limestone. So limestone is calcium carbonate. And if you heat it up, you get rid of the carbon dioxide and you get left with calcium oxide, which is quicklime. You then add a bit of water to partially hydrate it, and you create calcium hydroxide, which is lime. That lime then is used in construction. You add a bit more water, you add aggregates and what have you. And then over time, the lime will reabsorb the carbon dioxide from the atmosphere to carbonate, to harden, and it will recreate the calcium carbonate. So the amount of carbon dioxide given off initially is reabsorbed over time, and it does take time. I mean, I have seen lime in Hadrian's Wall, which has been underneath stone, which has not carbonated yet. So it can take thousands of years unless you expose it to the right conditions, which is it needs to have moisture available and it needs to have carbon dioxide available, because the reaction is actually it's a two-part reaction. The carbon dioxide dissolves in the water in the system to create carbonic acid, which then reacts with the calcium oxide to create calcium carbonate. So yes, most of the carbon dioxide that was given off gets reabsorbed, but you can't do anything about the energy you put in originally to burn it. So there's always a net negative impact because of the carbon that's been used to create the energy to do the burning. So I hope that answers the question.
Thank you, Mike. Do we have any more questions for Mike, Jasmine?
I've not seen any specific ones come through in the chat.
Okay, if I could just ask you a quick question then Mike, which is what sort of policy developments or incentives or other sort of enablers might there be that would help construction from biomaterials really take off in terms of becoming mainstream, becoming, if you like, the norm, as opposed to being something that's relatively novel at the moment still?
Okay, so there are a number of issues, some of which we are addressing directly, and some of which are policy and technical issues which need addressing. So in terms of the way in which we can get our materials accepted by the construction industry, the only way of doing it is certification, because people will not want to build with anything which cannot be guaranteed, warranted, insured, and against which people can lend money. And they will only do that if they have third-party warranties to say that it's a good material. And the way to do that is to get certification. And we are going through the process at the moment of getting BBA certification for our construction system. There are other certification systems out there. They are difficult to know which one is best. We feel that most builders, most insurers, most warranty providers know about BBA and are prepared to accept it, which, whilst it's expensive, does give us a quick in to the market. NHBC have a different system, and we will probably be approaching them armed by our BBA certification so that they can tick a few boxes and say, okay, if BBA say it's okay, then it's fine with us. In Europe, it's different. You need ETAG certification, but most of that is an outcome of tests, which are the same tests that BBA will do to give us the certification. So again, we can go armed with those tests and then tick the boxes. And if they need extra bits, we will do that. So that's that side of it. We can only through certification can we get wide adoption, because then they trust. The other issue, which is more challenging, is that the way in which environmental impact is assessed. You do this A1 to A3, but the RICS say that you should not account for biogenic carbon, which means that the big benefit from bio-based materials cannot be taken into account. So when a construction company says, I want the lowest carbon development, we can't say, well, you're using bio-based materials, that's low carbon, we're good to go, because we can't use that. Now in France, in Belgium, in Holland, they they have a different approach. They say, yes, you're absorbing the carbon for the lifetime of the building, so you can take a benefit of 100% at the beginning and a disbenefit of 50% at the end. So you basically get a 50% benefit, and that will allow us to outperform any other system. But the problem is, in the UK, they've explicitly refused to do that. Although there is a sort of get out in the RICS document in their Annex N, which says that you can talk about it, but in terms of the bottom line numbers, it's not there. And that is a big problem because people only look at the high level numbers. So that's my biggest issue, really.
Okay, thank you, Mike. We've got, I think, another question in the chat, but I think we'll save that for the end discussion because see, Jamie's now up next. So yeah, I'd like to introduce our second main speaker, who is Jamie Bartley, who's CEO of the Unyte Group, including Unyte Hemp. And Jamie's presentation is on the challenges getting from field to market. Over to you, Jamie.
Stuart, and welcome everyone. Thanks for joining today. My presentation might be slightly short actually, because Mike has just covered off really well and eloquently a few of the subjects that I was going to go into. So I'll try not to delay on too many of those, but hopefully it'll be some various different pieces in here that will be of interest for everyone. So a little bit about who we are. As Stuart just said, I'm the CEO of the Unyte Group. We're established in 2019. We've got various different business units, but ultimately our focus is on decarbonisation of the built environment and improvement of human and planetary health. One of our roles is with a secretariat to an all-party parliamentary group that's focused on industrial hemp, which has had quite a lot of traction and interaction with various different government departments, and we've recently had some changes to the hemp licensing off the back of quite a lot of lobbying work we've been doing over the last 3 years, so that was a positive move. We're the largest UK licence holders for industrial hemp. For those that don't realise, you need to have a licence from the Home Office to cultivate industrial hemp in the UK. So yeah, we have quite a lot of interaction with the Home Office around the licensing, and we've also been undertaking large-scale field research since 2019, which is now ongoing through the CHCX3 project as well. As I mentioned, we're very much focused on decarbonisation, and we're always open to collaborations and partnerships. So feel free to reach out if you think there's anything you'd like to explore in further detail. So initially, I'm just going to show you a little bit of a video which shows you basically from the initial seeding, the hemp seed in the ground, right the way through the process to the manufacture of various different products. And again, some people may be aware of the process, hopefully others won't be as much. That's playing for everyone. No, we drill the seed in sort of mid-April to mid-May, depending on the weather. You need the soil temperature to be above 8 degrees consistently. But once you drill it into the ground, you don't need anything, just sunshine and rainwater. And in the UK, it actually grows to about 4 metres tall for some of the fibre varieties in sort of 4 to 5 month growth period. Generally, we don't use fertilisers, pesticides or insecticides. Some fields might need a little bit of nitrogen depending on the nutrient content. And it can absorb up to circa 20 tonnes per hectare, which is 25 times the amount of carbon dioxide that the same size area of rainforest would sequester out of the atmosphere in just its 4-month growth cycle. So you can understand why it can, as Mike was alluding to, that the amount of carbon it sequesters through the photosynthesis allows us to lock that carbon up into the buildings. And then depending on your end uses, there's a few different harvest systems we use in the UK. That's one example there. And this is a forage harvester with a Kemper header on it, which is used for maize as well. It's a very robust crop, so you do have to use really tough equipment. We did a lot of learning in my first years about what not to do, as well as what to do with the crop. Spent 18-hour days hanging out of hemp harvesters trying to cut hemp that had wrapped around shafts off. But yeah, certainly it's a really, really interesting crop when you get in amongst it. The biodiversity in the field absolutely hums with insect life as well. So, and then once we harvest it, we wet it in the field for about 2 to 3 weeks, and that's a process that naturally allows the microbiological activity to break down the lignin, which is the natural binder of the binders, the bast fibres, the outer bast fibres, to the shib, which is the woody part of the core. Again, the retting process doesn't need anything other than just moisture and a bit of sunshine and a bit of air on it, so it's a natural wetting and drying process that goes through. That's an example of the seed harvest. So if you're taking the seed off before you harvest the straw, so again, you could potentially have a few different value streams there for farmers. And then after the retting process, we bale the straw, and then it can be stored until it's processed. And that process is it's called decortication, and it's quite a robust process. It involves hand mills, etc., and then various different combs to separate the bast fibre from the sheaves. So that's how it starts off when it goes into the decortication, and that's how the fibre comes out, the bast fibre, and then that's the wood sheaves that come out. It's a secondary process. You also get a dust fraction that's produced. So apologies, we just jumped back to the harvest end. We've done the harvest already. And then you can see the various different fractions there that then go on for further processing into finished products. So some examples of hemp packaging and hemp composites there. Some fibre insulation, which is one of the products that we're looking to scale. And then you've also got composite boards, various different fractions of those. And that's an example of hempcrete blocks that Mike was discussing earlier as well. We're also looking to, as Mike is looking to use modular hemp systems, which ultimately are combined into sustainable, healthy homes for people to live in, which we really see as a future of low carbon construction for the UK. And they can also be used in a lot of retrofit as well. But the fibres can be used for textiles, various different types of textiles, some of them blends, some of them different applications, and then those can also be used in biocomposites as well. And the hemp seed's a really nutritious seed. It's the most nutritious seed we can grow in the UK. And then when it's processed, we get protein powder, which can be going to plant-based meat substitutes, for instance. And we also get the hemp seed oil, which has a great balance of omega-3, 6 and 9. It also has all the essential amino acids we need to function. So like I said, a really nutritious seed oil there. And all those amazing products from just one crop and one harvest, in essence, if you use the right equipment. But there's lots of other things. You can look at bioethanol, green hydrogen, bioplastics, various different end products that we're exploring, and also batteries, supercapacitors as well. So hopefully that gives you a bit of an understanding how hemp is a solution that our planet really needs, and we really look to scale it. A little bit of recap of the process then. So we've got the hemp, we go through the harvesting and then baling. We've got the primary processing, decortication, which separates the fibre and the sheaves. And then the fibre can go into insulation, so non-woven insulation. And the sheaves can go into hempcrete or hemp seal, for instance, that Mike was talking about. And then the products are recombined to make a really low carbon house at the end of it all. So now some of the barriers that are really sort of preventing these products scaling in the market. So one of the barriers is the infrastructure. Due to the tensile strength of the fibre, it's the highest tensile strength plant fibre that we can cultivate on the planet. So really robust fibre, but that means we need very specialist equipment to process it, separate it and refine it. And that means that we need high levels of capital investment into that infrastructure, because ultimately, if we're going to start competing with conventional construction materials, we need to be producing the materials at the same sort of scale that we're going to need. As Mike said, 300,000 houses a year going to be built over the next 5 years in the likelihood that Labour getting in the next election. That means huge volumes of material. And if we're going to have a real impact on changing the dial and shifting the dial to bio-based materials and low carbon infrastructure, we're going to have high volumes of that production facilities and manufacturing equipment, which means we need to get the capital investment in place, because ultimately the factories will take 18 months, 2 years to build as well. And like I just said, the end use market is so huge that, to give you a bit of an understanding, we're looking to build 5 facilities around the UK. Each of those facilities needs 60 million of investment. Each of those facilities will need 35,000 acres of hemp cultivated each year as a feedstock. Even with all 5 at full capacity, we're only producing 10% of the UK's annual fibre insulation usage. So it gives an idea of the huge volumes of investment needed into infrastructure to enable us to really shift the dial for construction. A brief recap on some of the other products. Like I said, so we've got hempwood as well, which is another product that we're looking to bring to the UK. It's manufactured in from a US company, and it's a composite flooring product that again is a replacement for oak wood flooring, but it has a 20% higher density, and again it has far more regenerative resource because we can cultivate hemp year on year in a crop rotation, whereas if we cut down trees, they can take 10, 20, 30 years to grow, depending on which trees we're using. Most of those we've covered off. Hemp logs is another product as well. Again, from that waste fraction, that can get compressed and then it could be used as a fuel. Obviously, though, that does emit the carbon back into the atmosphere, which is something we try and avoid with all of our use cases for the product, for the crop. A little bit talk about market potential here again. I mean, this is some great work that the Hemp 30 project, the biorenewable, sorry, get my teeth back in, the Biorenewable Development Centre at York and York University undertook a few years ago. And it really is looking at the potential scaling capacity of where we are at the time in 2021, 2022, which is around 800 hectares of hemp being grown in the UK, and where we could go to if we really sort of look to scale that to the volumes that we think are needed to really start supplying some of these markets. And I can appreciate that people can't really see the detail here, but the main point here is that construction potentially is the biggest market that the hemp could go into. The predictions could be valued at £240 million by 2030 if we sort of scaled the production and the infrastructure needed. So again, it just gives that real context that it could have a huge economic impact to the UK as well. Some of the problems and policy issues, and again, Mike covered off these really well earlier, but one of the big issues is around the biogenic carbon that Mike was discussing, and the fact that hemp sequesters all that biogenic carbon into the biomass. You can see an example of a crop that was grown in Shropshire in that photo there, and the root is around my sort of knee height, and as you can see there, that was just before harvest, and that was 4.2 meters was the tallest plant that we located in the field. So huge amount of biogenic carbon stored. But when we turn that biomass into construction materials, we undertake a EPD, an environmental product declaration, and that EPD process doesn't allow us to value the biogenic carbon into the product. So one of the biggest issues is the way we calculate the declarations for products and how we really attribute the environmental benefits that those products have into the end certification process. There's a lot of work being done to try and sort of push embodied carbon in construction, because at the moment when we procure construction materials, we procure ultimately on cost and quality alone, and there's no accounting for carbon. If we were to account for life cycle analysis in that procurement process, and therefore we're looking at embodied carbon alongside cost and quality, suddenly then bio-based materials absolutely come to the forefront. But again, it's working with government, something that we do via the APPG, to really work on sort of pushing this point and looking for policy and legislative change, which ultimately then drives investment into the infrastructure needed to provide the alternate materials. And there's also insufficient regulatory frameworks around data and how it's actually sort of generated. There's, for instance, Rockwool on their insulation, their mineral insulation. Their process is mining rock out the ground, heating it up to about 1600 degrees Celsius, and then fibrillating the fibres that are produced into a fibre insulation. But you look at their life cycle analysis, and they don't include the carbon emissions from the mining of the rock. They don't include the carbon emissions from the heating of the rock to produce the fibres. They just start their life cycle analysis at the processing of the fibres into an insulation product. So there's so much misalignment with how different life cycle analysis or EPD data is generated, and therefore that unfortunately slants the procurement process, slants specifiers and architects to products that aren't necessarily what they say they are. I think we will see a standardisation and a sort of a global movement to avoid the greenwashing that has been happening a lot of the time, but ultimately it's not happened yet. So it's another barrier that we need to overcome for these bio-based materials to really be adopted en masse. And we, like I said, we need that unified standards, improving life cycle analysis, and that will promote the use case overall. So there are some great success cases. Again, Mike was mentioning BBA, which they're working through at the moment. So Indie Nature, a company up in Scotland, they're the first BBA certified UK cultivated and manufactured hemp insulation product. It's a fibre insulation, so their hemp's cultivated by East Yorkshire Hemp up in Yorkshire. It's processed there, the primary process for decortication, and then the fiber's taken up to their secondary processing factory, their insulation line, which is up in Jedburgh in the Borders in Scotland. And again, as Mike said, it's a long process, it's a costly process. Specifiers do generally lean towards BBA. It's not actually a legislative requirement, but unfortunately, people specifiers look at it as a comfort blanket or a safety net, so to speak. So unfortunately, it is a process that innovative products need to go through. It does take a lot of time. It is very costly, especially for startups. But ultimately, if we're going to look for these materials to get adopted at scale, we need to have these certifications in place. There are global inconsistencies as well around these different certifications. Again, Mike covered that off. ATG is an equivalent in France or Belgium to BBA. They do a sort of cross certification process, which they will look at the testing that's been done for one and potentially certify it under the other. But again, it's not as streamlined as it could be. But back to the point, it can be done. And Indie Nature, a case in point of having achieved that over the last, I think they've been on that process for 18 months to 2 years. So yeah, it's a long process. This is another use case that we're quite heavily involved in, and again, it really brings to that circularity piece that we can look at ultimately cleaning up land via phytoremediation using crops, and it can be lots of different crops. Willow, for instance, is another use case for phytoremediation of this contaminant that I'm going to cover here, which is PFAS. People may or may not have heard of PFAS or PFOS. It's also termed a forever chemical, and it's used in various different materials. Teflon, for instance, non-stick frying pans, a lot of waterproof clothing. That's PFAS and PFOS. But one thing that's sort of really been overlooked is these compounds, they don't break down in the environment. They don't break down in water. They don't break down in soil, which is why they're termed forever chemicals, which means that some of their positive attributes to where they're used is also a negative attribute to the environment. And there's actually quite high levels of PFAS and PFOS now being recorded in drinking water, in sewage sludge, for instance, and the sewage sludge then gets spread on the agricultural fields, which then means that the crops uptake it. So concerningly, it's quite heavily in our food chain for all different areas. Firefighting foam is another source of it as well. And we've been working with hemp to look at phytoremediation. So hemp will suck up lots of different contaminants, and it's actually a hyperaccumulator compared to other crops as well. And a hyperaccumulator means it can suck up far more levels of potentially ecotoxic contaminants that would prevent or kill off other crops or other plants from growth. So that means we can use it, and again, because it's a tall crop, it has a very deep taproot as well, which means again it can access contamination at depth and potentially suck up that contamination. And then this graph on the right hand side actually shows you where different PFAS and PFOSs are stored within the plant, and actually quite promisingly it shows that the majority is stored in the leaf. So that means that if we're going to clean up areas of contaminated land or agricultural land that's impacted or brownfield land that's impacted with PFAS or PFOS, we could also then harvest that leaf and destroy that leaf, or even potentially land for that leaf in a specific location to contain the contaminant, and then still use the straw, the biomass, to go into construction materials without risking spreading that PFAS and PFOS contamination into other locations. So some really promising circularity there, where we could actually go on to poor quality land. And it's not just PFAS and PFOS, there's other contaminants it'll work with as well. But by clearing up those contaminated lands, this is another example, you can use it on fracking muds. TPH is hydrocarbon contamination, and we can clean up those hydrocarbons or that heavy metal contamination as well. And then once we've cleaned that contamination up, we can use the biomass to produce construction materials to build houses on that poor quality land that we've cleaned up over a couple of cultivation seasons. So I mean, you're talking 2 to 3 years of cultivation seasons. It won't happen in 1 year. But again, it just shows that there's some really interesting cases to explore around bio-based materials as a whole, and actually utilising poor quality land, remediating that land, and then having the benefit of the biomass that we've used to clean up that land, plus all the carbon that's locked up during those cultivation cycles of remediation. So hopefully that's giving you a bit of an understanding, a bit of a deep dive into some of the various aspects of hemp in construction, and happy to take any questions.
Thanks very much, Jamie. I can see that there is already one question for you, which is around the conditions necessary for growing hemp in the UK climate. And the question really, I think, which probably for you perhaps, and also perhaps for Mike as well, sorry, for Jim as well, is there anyone testing its productivity on peat soils?
Certainly. So the UK climate, so we need the soil temperature to be above 8 degrees when we plant the hemp seed. Generally, it will grow anywhere from the North Shores of Scotland right down to the South Coast in England. It's a really hardy crop actually as well. It tolerates drought quite well because it's got that deeper taproot. It will get down into the moist soils. So as long as you've got a little bit of rain at the beginning when you drill the seed and you've got a bit of moisture in the soil, once it germinates and it starts getting its taproot down, there's nothing really stopping it. I mean, I've seen some of our cultivation trial crops in 2018 and 2019. There was a couple of years, actually more recently as well, last year, we had a couple of days of 40 degrees sunshine, and then it was hit with sort of 70-mile-an-hour winds in a couple of days afterwards, and the crop's still standing tall in the field. You might have 5% of the crops blown down, but you're looking at the surrounding fields and they're absolutely decimated. So, I mean, it is a really resilient crop for the UK to focus on. In relation to peat, no, I'm not aware of anyone actually cultivating on peatland. I think it would be a really interesting one. I know that it doesn't tolerate very waterlogged clay soils, so were the fact that it could have very high water levels in the peat, that might be an inhibitor to the growth. But it'll be an interesting one to trial potentially, certainly.
Yeah,
Thanks, Jamie. Jim,
did you
carry
want-
on.
Yeah, did you? I haven't heard of any trials on certainly wet peat soils. It sounds like from what Jamie was saying there, it might not be ideal, but you know, it's certainly this is the time to test it if to see if it would work. I think the problem we've got with peat soils, which you haven't got with your with hemp and your other crops, is that we're working on soil with very low carrying capacity. So you know the equipment that you showed in the video is likely not to work in a pizza. So that's one thing that we're trying to explore. You know, several projects are looking at different ways of mechanizing, you know, gathering this stuff. So yeah.
Thanks, Jim. Jamie, there's another question for you, which is in terms of phytoremediating, could the hemp leaves be used within products, or are you suggesting that they would need to be stored safely, so not used, in other words, or buried?
I think that it's something that's being explored in detail at the moment. I mean, the risk is that especially with PFAS and PFOS, because that is stored in the leaves, you wouldn't then want those contaminants ultimately going back into the environment. So I think biochar, potentially pyrolysis, is something, but again, you need to get to temperatures that are suitable to break down. Or there might also, but I know there is some work being done around looking at whether we can use mycelium to potentially break certain myceliums to break down the contaminants. And then again, as long as you can break down those fractions, so ultimately they are going to biodegrade in the environment, then yes, I think there is options for looking at utilizing the biomass. But you need to be very conscious that you're not allowing the release of those contaminants you've phytoremediated.
Thanks. We've got another question from Chris Bell, which is, Jamie, every time I look at it, hemp seems to be the wonder product and the economics are incredibly profitable. Farmers can make thousands, so why isn't it everywhere?
Yeah, absolutely, Chris. And the biggest barrier is that infrastructure piece. The farmers would love to grow it. I've got 250 plus farmers on a database that have contacted me over the last 8-9 years saying, Jamie, can we grow hemp for you? And it's the same conversation with every single one of them. I'd love you to, but I need to have £60 million worth of factory to be able to make products that are commercially viable for the end use markets that we're looking at. And again, it's back to that biogenic carbon and embodied carbon piece. Unless that's valued in procurement, we have to be at the same cost comparison to conventional materials, and we only do that by doing it at that high industrial scale, which means unlocking 60 million of investment into the infrastructure. So unfortunately, it is that piece of the high volume of investment needed into infrastructure and lack of sort of government investment into kickstarting that piece as well at the moment, other than the research project we're obviously involved in.
So if the money isn't going to come from government, Jamie, where else might that investment come from? Can we learn from anything, for example, from Europe, where obviously some countries do grow larger areas of hemp? How have they managed to make that infrastructure work, investment work?
I'm not 100% from European perspective, but I mean certainly from our perspective, Stuart, we're heavily exploring the carbon markets. So we're currently in sort of fairly developed conversations around, and also verification and listing around pre-selling the carbon credits onto the voluntary carbon markets to then raise the finance to allow us to build the infrastructure. We'll sell those at a massive discount to the value of those carbon credits if they were currently live in the markets, but there's quite a few banks potentially that are interested in that, and that's something I think if we can make it work for the first one, then it will absolutely get replicated, and we're very open and collaborative, so it's the kind of thing, if we can make it work, we'll be telling everyone from the rooftops how to do it too, so we can really see infrastructure rolled out, because our goal is ultimately is scale impact.
Great, thank you. Yeah, and it looks like Chris has offered to start the process on whipping round for the 60 million. So we sit back for your contribution, Chris.
Thanks, Chris. Good stuff.
Right. With that, not much ado, we'll move on to our final presentation. Thank you, Jamie, which is from Joanne Booth, who is the business manager for construction for Lucideon. And we've already touched this on it very briefly, but Joanne is going to tell us a lot more about certification and barriers or enablers.
Hi, am I sharing?
Not yet.
Oh,
We
I'm going
can
to
hear
share.
you.
Yeah.
We can hear you, but
Okay.
oh yeah, you just started sharing. Yeah, that's good.
Yeah. So you can all hear me? Yeah.
Yeah, we can hear you.
Yeah. Lovely.
And
Right. So I'm Joanne Booth. I'm, as I've just been introduced, the business manager for construction in Lucideon. Lucideon is based in Stoke-on-Trent. We're a research and test lab. We work across multiple sectors, including healthcare, aerospace, nuclear energy, and construction. As you can see, we have lots of material scientists and engineers. We have the largest commercial construction testing capability in the UK, and we carry out structural and environmental testing of building components, systems, and full buildings. So we've seen lots and lots of different things coming through our lab over the years. So today, why do we need testing? I'm covering different options for testing, which allow you to place your products on the market, going from sort of bespoke, customized test programs right the way through to the third-party certification, with some pros and cons against that. I think we've already heard from Jamie and Mike. They've had some experience with that aspect. There is other options out there. You are limited when you've got a non-standardized product, but there is options out there. So why do we need to test? Well, for a start, it's a legal requirement to apply a UKCA mark to a product if there is a route available. In your case, there isn't necessarily a route available. If there was, you'd have to do it. The Building Safety Act came in 2022, and its requirement to present data from a qualified source. That Building Act there was, its remit was to oversee the safety and standard of all buildings and to help encourage building control professionals to improve their competence. Obviously, that came from the Hackett review, and particularly in the last 12 months, that has really been pushing a lot more testing through our labs. So new products or systems will not be accepted by insurance bodies. So when we're talking insurance bodies, we're talking people like NHBC, Premier Guarantee. They are not approval bodies themselves. So if you're using a product on their site, they have to see something to prove that that product does what it's supposed to do. So unless it's UK CA marked or certified or something backing it up, they will not accept that product. And we've already had that from Mike and Jamie. I mean, basically, you need the data required in the design of the buildings as well. So, you know, that's a biggie. If you don't have that data, you can't use your product, you can't design the buildings, it's not going to get signed off. And then I'm sure we've got some architects and engineers in here, and they don't want to see untested products on any of their designs. So there's different ways of proving acceptance and performance of products and systems. So the easiest one is testing to European or British standards. And then we have the European assessment documents, the EADs or E-tags, as they used to be. And third-party certification, which you've got your BBAs, your BDAs, your TRADAs, UKCA mark or CE mark, which always requires going back to the EN and BSs, and then testing by UCAS test laboratory. If you've got a customised test program, you can use a UCAS test laboratory and you will get a certain distance with that. So if we just whip through each of these areas. So European standards. So construction products fall under the construction products regulations. And under that, it is a legal requirement to apply UKCA mark to a product if there is a route available. And there isn't always a route available, but if there is, you need to do it. So UKCA mark can only be applied if there is a harmonised European standard. So the product must match the definition within the standard. So there might be a harmonised European standard for a walling board, a cement fibre board that's going to get used as a sheathing board. If you don't match the definition within that standard, so if your material isn't the cement particle board, it's something else, you can still test to that standard, but you won't be able to apply a UKCA mark to that standard. And there's testing classifications within those standards. So if you have a harmonised European standard, at the back of that standard, there's an Annex ZA. And that Annex ZA contains the requirements for what you can do yourselves and what you need to be carried out by a notified body or a UCAS body. Very dull slide, that one. Don't expect you to kind of look through that slide. But there's different levels of attestation. And basically, a level 1 and a level 3 mean that if you have a level 1 or 3 product, you have to have that tested by a UK notified lab. So somebody like Lucideon. For levels 2 and 4, there's no requirement to test by a UK notified lab, but you do need to have your factory production control carried out by a notified lab. So there's additional levels of requirements there. With a 1, you need both. You need factory production control and notified lab testing. So European approval documents, Mike mentioned earlier, there was E-tag route. So the E-tags have now become EADs. And the EAD is a route to apply a UKCA mark to a product. And that's a product that hasn't already got a European standard against it. These are written specifically for a product or system. So this is an alternative to going for third-party certification. Not much of an alternative, it's got to be said, because you still require one of the certification bodies that which are written there, BBA, BDA, DIBT, Zeus, Strada, who are also the third-party certification bodies, to write that for you, to commission that. Those EADs have 5 different levels in there that you need to look at. So structural performance, environmental performance, durability, health and safety, obviously always fire. I've put the EOTA website on there. The EOTA website contains all the EADs that are out there. And there is some EADs for natural products already. There's certainly one for straw bales used for housing. If there's already an EAD and you fall within that EAD, so if your product is identical to the description of the product in there, the identical materials and the identical way in which it's put together, you can use that EAD that already exists. So you can go in and you can get your product tested to that. If your product doesn't fall exactly into that EAD description, then you would need to get that written for you and commissioned for you. You're looking at a good 18 months, which is similar to the third-party certification process. But with the benefit of this is that you can apply the UKCA mark at the end of it. Yeah, there is like a lot of, if there's a standard that you want to use, so you've got a product that's similar to an EAD that's already out there, which falls outside of it, you can use that EAD as a basis of your testing. So instead of starting from scratch, you can say, well, mine's so similar to EAD XYZ that we can take that, adapt it to your particular requirements and use that, which saves you a little bit of money and a little bit of time. So we're on to third-party certification. So Mike and Jamie have mentioned this, that they've had dealings on third-party certification. I have put pros and cons. We do work with the third-party certification bodies, so we have to be careful on the cons. So there is various ones out there. So we have BBA, and the BBA has such a great brand that people do sort of use it almost like you're using a Hoover. So a Hoover, you're vacuum cleaning your house, you might be using a Dyson, but you're hoovering up. So the BBA, people say, have you got a BBA? Have you got a BBA certificate? And that, instead of it being a BBA, the BDA keyword certificate is exactly the same. TRADA, UL, all exactly the same. But the BBA's got that brand out there. So you'd be saying, yes, I've got a BBA and handing over your BDA. Great brand. Each of those certification bodies have got different strengths. So UL, they're very much into facades. TRADA into wood-based products. So TRADA are probably a better solution for certification, for understanding the properties more of the materials that we're talking about today. But like I say, the BBA, I've got that really good brands. The BDA keyword are coming up behind them and they're taking a chunk out of the market. But still, I've got, yeah, a long way to go on the brand recognition. The third-party certification compared to the going through the EAD route doesn't allow you to provide a UKCA mark. But the NHBC will just accept that. If you hand that over, there's no questions asked and you won't really need that UKCA mark anyway. And they do require certification for anything that has not got that and is a sort of material that's not recognisable. And the levels of performance that would be required for a product that isn't known, hasn't got material properties and hasn't got any history out there will be higher. So we'll expect a higher level of proof that that product does what it's supposed to do. The third-party certification involves the factory production control, so they will come out and assess your products. With something like your natural materials, the thing that strikes me is that you need to keep that consistent. So, you know, if you've harvested in June, is it still the same as the product that you harvest in September, for instance? As soon as you've got a lot of variation from that standard that you've tested against, so if you've sort of taken a crop and you've established various properties of that material or properties of that product, you need to be able to prove that that stays within a tight parameter, so that the tensile strength can't vary within certain percentages, the moisture contents, the dimensional stability, any of those areas that you will be assessing. The third-party certification also includes assessments against the building regs. So that's all in there. The EAD document doesn't, because it's a European approval document and it goes throughout Europe, then it doesn't include UK building regs in there. So that's also quite a nice, useful area. And they will include customised test programs in the same way that the EAD will. The customised test programs will probably, almost certainly, be based on similar European standards. So if you were coming to me with a sheathing board that was made out of your reed product, I would just take a sheathing board standard, look at that sheathing board standard, what do you need to prove from a basic sheathing board standard, and I'd probably I'd use all that sort of same test parameters, and I would expect you to be able to meet those across a sort of a period of time, so at least a 1 year period, to be able to benchmark that. So we have some pros and cons. So because we work with these people, I'm going to be polite on the cons. But on the pros, these certificates are automatically accepted by all the insurance bodies, so Premier Guarantee, NHBC, building inspectors, and across the industry, architects, etc. Great brand recognition on some of them. It gives a marketing advantage as well. So sometimes people will go through the third-party certification process when they don't necessarily need to, just to grab that marketing advantage, which then chucks people into having to do the same to keep up. Because otherwise their product will get chosen over the non-branded product. There is a thorough testing and assessment program in there, but all that can mean it is very slow. So there is various reputations out there for it being a very slow process. Mike mentioned 18 months, which people seem to think was quite slow, and I was like, wow, you've done well. If you've got that in 18 months, you've really moved on. You generally can be waiting 3 or 4 months just for an answer back on whether you can get an appointment. It is a very expensive process. You do have all the testing costs as well as the certification costs, and then the certification also needs continual surveillance as well. So you will get surveillance costs. And then I think it's either 3 years or 5 years you will get a reassessment cost as well. Communications can be poor as well, so you can start your process and then everything will go a bit quiet, and things don't seem to move on. It'll go into a black hole. That's probably standard across many things, to be honest. I don't want to start pointing fingers, but there is a reputation there for that lack of communication. We deal a lot with the third-party bodies, and we'll get to the end of a process for somebody and then they'll suddenly have another round of testing that have been thrown in at the end that slows things down. There is a lot of accused of stifling innovation that's bandied around. I think there is a lack of, for a product like yours that hasn't had any much history to it. Well, you could probably say it was used hundreds of years ago, but sort of modern history, if you like. There won't be any experts, or you'll be very lucky to get an expert in that particular product at the certification bodies. Hence, they will rigidly assess that product against the available product standards, and be fairly stringent in that. So if something isn't really relevant to what you're doing, they'll still expect it to perform in the same way. So you could say, oh, this board is never going to get wet. It's always going to be dry. So the effects of moisture will never have any effects on this board. So we don't need to test that, but it's in the standard. So you will have to test it and you will fail. And you might fail due to the fact that something that's never going to happen to that board. But you're stuck with that, unfortunately. There is UCAS accredited testing. So again, if you want to apply a CA mark, you have to go through a UCAS accredited test facility for attestation levels 1 and 3, not for 2 and 4. But something like if the BBA are doing a certificate for you, they'll only accept UCAS lab produced data. So that can also be a problem. So if a test standard that they've requested isn't a level 1 or 3, so it doesn't necessarily need UCAS accreditation, it costs a lab to get UCAS, so they don't bother to put that on their schedule, and hence there will be very limited test labs available who would be able to carry out that test process for you and hand that data over to the BBA. The BBA will come out and assess a lab if they haven't got UCAS accreditation for a test, and they will audit, but that adds costs and it also adds time onto the process. Marketing advantage again, you can say if you've got a product that falls outside of a European standard, you can still test at that European standard, you can still claim compliance to it, you can still do your DOPs, your declarations of performance against that European standard, but you won't be able to go that extra step and add the UKCA mark, but you can still do everything else. So you can still say, this board has been tested to BSEN 12467. It's passed all the criteria. It's equivalent to a cement particle board of the same grade. Here's all the DOPs. So exactly the same marketing information out there, but you wouldn't be able to apply the UKCA, which would then probably stymie you with getting it accepted by an HBC and Premier Guarantee. Sometimes you get lucky and sometimes you get and you don't. But that does give you a marketing advantage because it gives you all that information in the same way as a standardised product. Using a UCAS accredited test facility also ensures testing is carried out by a competent body. UCAS facilities are audited yearly by UCAS, and there is pass and fail criteria. So yeah, UCAS accredited testing that is accepted by insurance bodies in place of certification if known standards are employed and followed stringently. And UCAS tests are primarily on BSEN standards and not customised, so again can be limited because you don't always put that on there because of the cost involved. So in all fairness, I think it's doubtful that the EN route and being able to apply a UKCA mark to your products is available. You can test to the EN standards, you can test by a UCAS accredited lab to the EN standards, and you can declare all your declarations of performance and your class levels, but you wouldn't be able to go to that extra level and apply the UKCA mark. But there's nothing stopping you doing all the rest of that. Yeah, so you need to test all the material properties of your product as well as the system properties. So if you've got your hemp material, you're going to make it into a board, you need to be able to prove that the board properties are in line with the product standards. So you need to prove that the tensile and the dimensional stability and the ability to produce, resist water, all that sort of stuff actually works as a material property. But you'd also need to be able to prove the performance of that product as a product. So if you were producing a floorboard, you need to be able to test it as a floorboard. So you need to be able to get all the mechanical properties of the actual product, and you also need to be able to prove all the mechanical properties of it as a system when it's in situ, so as a floorboard as well. So is it able to resist the point loads, the Eurocode loadings, the impacts, all that sort of stuff as well. So there is 2 sets of testing that you would have to do there. The material properties, which would, for many things are already known, but for yours are not. So you'll probably get a higher level of requirements for that. And then the system performance as well. I mean, I think really to actually get to the end point on the market where you're going to get sign off by your certification by your insurance bodies, then I think really you'd be looking at the third-party certification route or the EAD route. I don't think there's much difference really in the money, and I don't think there's much really difference in the time. The EAD would be acceptable across Europe, whereas the third-party certification probably wouldn't be since we came out of Europe. So that's me. Thank you for listening. Hope I didn't rattle too much.
Thank you very much, Joanne. I don't know if you want to put yourself on camera or whether you want to stay as you are, but we do have one or two questions. So I think the first question is around the route to EN. So I think you've indicated it's doubtful that it would be available at the moment. Yeah. Is there anything that might change there?
You would have to you would have to get a group together, an interested group, and go for writing a new standard. That's probably even worse than going for certification. It'd take you, God, you're probably looking at 5 to 10 years before you get something in there. So you really have to have a long look ahead of that, if that's a route you wanted to go. And I think you may struggle as well because I think there's probably so much variety in the products that you want to use. So you're looking at the product specification, so the material specification of lots of different products, and then looking at using that in different aspects. So using that as a flooring, as a walling, as an insulation. And I think if you started to go down that route, I think it'd be a great thing in the end. But I think you really need that kind of forward loop before that would be viable.
So there's a second question also from Mike Lawrence, which is, what is the process to achieve a new EAD?
So the EAD, so you need to go to one of the EOTA members. So like I say, in this country, that is the same people as the certification bodies. So that's, you go to BBA, you go to BDA Kiwa, you go to TRADA, probably TRADA for your, that's a Timber Research and Development Association. I would have thought that they would understand your materials much better. And you can commission them to write you an EAD. So you'd sit down with them and you discuss, right, this is my product, this is my material, and this is the product I want to get to the end. They would then pick out all the sort of similar standards, because that's the easiest way of doing it, is just to go, well, actually, it's so similar to this, I'm going to use this, and it's similar to this, I'm going to use this. But with the EAD, I think they would consider being less rigid and following the ENs. So with the certification bodies, they will just sort of take an EN and copy that. With the EAD, I think there's more consideration over that particular material. So we're not expecting, if you say, right, this is never going to get wet, so we won't ever expect to have to test it as in a sort of wet situation. Whereas if you were sort of copying something else that was out there, a European standard that was out there for, say, a sheathing board, you would expect to have to wet that material and you might not get the performance. So once you've written the EAD, so you have a specification, so it has to follow all those different criteria. So you have to fill the health and safety and the fire and the structural, environmental durability, all that sort of stuff. That gets written, you have to do all the testing in line with that, factory production control, and then that has to be, all the test data and that EAD has to go off to all the EOTA members. So that has to go off to everybody you haven't engaged with anyway. So that gets sent off all around Europe to all the EOTA members, and they have a 3-month period of time to be able to comment on that. If they come back with comments, you then have an 8-week period to address any of the comments. If they don't come back with comments, it gets written, it gets sent out again, and they're not allowed to look at any new comments at that point. But they are able to kind of throw back anything that they've already commented on that they're not happy with. So you're looking at another 8 weeks on top of that. So I think, to be honest, when I'm saying 18 months, it's probably, yeah, I'm probably being generous. It's probably more than that, really. But you're looking at that sort of level, and you're probably looking at the same sort of level as the certification costs as well, because it's the same people.
Great, thank you, Joanne. Yeah, I see there's already a discussion taking place after the webinar about how that might go forward. So that's good to see. Jasmine, are there any other questions for Joanne that I am missing in the chat?
I can't see any. I think that they are all the questions.
So I've noticed one from George Emma
okay.
Hunt, which you said quite early, Joanne, that if there's a route available, can you just clarify what that means and when that, if there isn't one, what that might mean?
Yeah, so that's if there's a route available. So if there's a harmonised European standard available, then you are legally obliged to use that harmonised European standard and apply a UKCA mark. So you have to have that testing carried out. You have to fulfil all the requirements of that standard. And that might be testing by a notified lab. It might be testing yourself in your kitchen. It's according to what level of attestation. It might need third-party notified lab, factory production control, or again, you might be lucky and it might just be, you can kind of just, you've written some bullet points down. So there's different levels there. But if there is a route available, so if you can apply a UKCA mark, you must apply a UKCA mark. With the EAD, you can apply a UKCA mark, but there's no, it's not mandatory. So if there is a UKCA mark, an EAD available that's so similar or the same as your product, you don't have to do it. You're not obliged to. So if there's no route available, you don't have to do it. So you can sell your product in theory without applying a UKCA mark. But the problem is you won't get that accepted by the insurance bodies because they want some assurance that product actually works. So then, yeah, if so you can just sell it. You can just go, right, I'm selling this product. There's no route available to apply UKCA mark. I'm happy that it does what it's supposed to do. I'm going to give some test data out there that I've produced wherever, and I can use it. And there's no reason why you can't use it, apart from you will struggle to get that accepted.
Thanks, Joanne. Yeah, I was going to ask. From what I've gathered, there are lots of different options here, lots of different considerations, lots of different processes, certification standards, etc. How does somebody who is, let's say, a new entrant in this area, sort of navigate that maze of different routes to work out what is the best way forward for them? Is there a simple process or a place people can go to actually, say, help them make a decision about how to go about getting that sort of appropriate certification or whatever for what they're doing?
There isn't really. I guess it's relying on sort of landing on the right sort of lab who will all sit and have a chat with you. Say if you commission if you decide it might be best to go for the certification, then contact the certification bodies. But somebody like BBA will want £5,000 off you to discuss possible test programs and routes. They always say that they refund that. Mike would know better than me whether they refund it. Personally, I think they probably just inflate the bill and knock that 5k off. But yeah, maybe I'm a bit immoral. So there isn't anywhere that I would say sort of go and talk to X or go and look up Y. I think really it's kind of just sitting down and hoping that you stumble on the right person. And there's some people out there who are helpful and some people who are not. Is it? So yeah, we're always helpful at Lucideon. Not promoting his here, but we do tend to sort of sit down with people and chat through, because yeah, it's interesting, and it's always interesting seeing new stuff and helping people to get to the marketplace. But no, I couldn't advise to sort of go somewhere. You really kind of got to hope for the best, really.
Yeah, it seems that it's if we really want to see this sort of sea change in the uptake of these sorts of materials within the construction industry and other areas of sort of industrial crop use, that some of these different elements we've touched on, some of them the need for investment, the need for licensing considerations, all sorts of things. But this too, all these things need to be in place if we are going to really see that change. And it would be great if there was an opportunity out there for somebody to pick up the mantle and take on the role of providing that kind of sort of independent guidance in the right direction. Got one more question just come in, which is where does Lucideon sit within the list of methods presented? Are you a UCAS test lab?
We're a UCAS accredited test lab. Each test, so we're a UCAS accredited test lab, but each test has to have UCAS, it has to be on our schedule. So we can't just say, oh, we're a UCAS accredited test lab, therefore everything within the BSENs we're UCAS accredited for, because that's not true. So you have to decide which ones you want to put on your UCAS schedule. And to be honest, you only tend to put on the attestation level 3, where people have to have testing done by a UCAS accredited test lab. If you don't have to, people can do it themselves. So it's really a market demand. We work a lot with the certification bodies because we have such good testing facilities. So BDA Key, we don't have UK testing facilities, so we tend to do all their third-party testing for their certification process. BBA have some, they're limited. They tend to do doors and windows very well. We're not competing in that area, so we also work with the BBA as well. So we're a UCAS accredited test lab. We also design, we work with BBA and BDA to design customized test programs. So when something comes along like this, then we will sort of work with the certification bodies to design the test program, hand that over and have discussions on that. Customers often come to us for that because we don't charge the £5,000 and it's already there, and then you can take that to the BBA and they can comment on it and it saves you some cash.
Great, thanks, Joanne. So I think we've now got a little bit of time. If there are any more sort of general questions, or anybody would like to sort of make any observations or make any suggestions about how we can address some of the challenges and opportunities we've heard today. So you can either put those into the chat, or if you would prefer to ask them personally, then feel free to raise your hand and we'll try and detect those, and you can come on screen, unmute and ask them personally. So yeah, floor is open really. We've got one more question that's just come in. A simple quick question from Mike: is Lucideon an EOTA member?
No, we carry out all the EAD testing and provide the EAD testing for the EOTA certificates, but we're not an EOTA body ourselves. That's a much higher level of risk to the company than we're willing to take. So we let the certification bodies do that and just provide the test data.
Thank you. Any more questions? Jasmine, are there any further questions you can see in the chat? Chat's temporarily disappeared for me. I'm just getting it back again.
It's all right. But I can see, I'm just checking everyone's responses to make sure that everyone who asked one was answered.
Can I?
Jim. Yes.
Sorry, yes, yes, just fighting with my controls. It seems it's the first time really I've had a sort of that in-depth presentation around the testing. I was aware that it was a barrier. It's certainly something that it's been talking about in my project, but yeah, so thanks very much for that. It all seems forgive me, but a little opaque, and it feels like there's space for both our projects for a tool or some something that makes it a little bit clearer. I mean, accepting that we can't change, you know, the landscape of testing from where we sit. But do you think there is scope for if we could find a means of doing that to make things clearer?
From our point of view, we've worked with a lot with the trade associations. So for example, we're working with a trade association who manufactures GRP products, so dormers and chimneys. And they got together, so there's no standards out there for them. So they were just being produced and put on an NHBC properties. And the NHBC suddenly decided that they're not going to accept those without any third-party certification. All the manufacturers got together and said, look, this is going to bankrupt us. It's really expensive and it's really slow. What can we do? So the NHBC worked with them. They formed the trade association. And we developed a test program with the trade association, and we got NHBC to sign that off. So all the testing of chimneys and dormers and bays and canopies, all made from GRP products, go through Lucideon. So we're not a certification body. We're not even got these on our UCAS accreditation. So this was a program of testing that we said, right, okay, what's a chimney? How does a chimney work? What does it do? What's it trying to resist? Come up with this program of testing, handed it over to NHBC. They signed it off, tweaked it, added a little bit more in, went back to the trade association and said, okay, you could sell your products. Anybody who's a member of the CGFMA has had the testing done and has had the additional requirements from the CGFMA on looking at their auditing, all their stuff, and kind of control of what comes out of their manufacturer's sites. And we will accept that onto all NHBC sites. So there is routes available to kind of avoid all that, but that requires lots of you getting together, okay, and pushing that forward. So with the CGFMA, one of the guys from Ibstock, so Ibstock have got more money. They're a big brick manufacturer, but they also manufacture these products. They were able to kind of go, right, this person is going to be, his job is going to be pulling all this together and doing all this and moving it forward, because we're all, okay, everybody's going to benefit from it, but so are we, and we're going to be in control of this association. So there is routes. You don't have to follow that. but you need people to get together, be passionate, and push it forward, and somebody has to lead it.
Okay. Yeah, so collaboration is key.
Yeah, really, yeah. And then I don't know how different your sort of products are, really. So you'd have to be careful not to kind of spread too thin on what you were trying to achieve.
Okay, that's useful. Thanks.
And then add bits in as you go.
So we have another question, which is, what are the prospects of new standards being developed for natural materials to ease the certification process? Do you see a role for academia to help with BS standards development for biomaterials?
Yeah, so it is a very long process, even if you've got academia. So because I mean, I was just involved in a new standard which actually went quite quick for magnesium oxide boards. So magnesium oxide used as a material for new sheathing boards. There was no standards available, but we did basically. I was involved in a committee where we wrote a standard for this new board, and it was quite quick actually. It was probably over about a 12-month period. I was involved in the committee on it, and I only just found out that actually that cost about £100,000. So, and that was just lots of volunteers spending their time, but they still had money that they had to pay over to BSI. So that came out as a PAS standard, which you can do quite quickly in comparison to doing a full BSEN, BS standards now. I guess we're not EN anymore. So there is another route, but again, it requires somebody to put the time in, to develop it, to do all the liaising, to get everybody together. And there is money involved as well. So it's not a free process. And that's not, that's not getting anybody paid. That is just sort of, the fees for engaging with BSI.
Thank you, Joanne. So I've got another question come in, which is probably best answered, I think, perhaps initially by Mike, which is TIFA has some interesting properties, e.g. no need for filler in boards. It's an opportunity for looking at mixed materials. Would that make too big a barrier for the testing?
Yeah, I don't fully understand about the concept of the no need for the filler in the board. I'd need a bit more clarity about that. But for sure, I mean, we're very interested in looking at a whole range of bio-based materials to see what we can achieve with them. Yeah, I think there are opportunities. It's just a question of finding the time to develop them. But that's what I do. I spend my time doing that. So yeah, if I'm given some materials, I will play with them and see if I can come up with some potential material which can be used in the construction industry.
Thank you. I think Elizabeth, carry on.
Do you want me to just comment?
Yeah.
So Aldert van Veeren, who couldn't be on the call today, I'm happy to make the link for you, Mike, is working with TIFA particularly. And they've shown that when TIFA is microfibrillated, you actually can form a board very securely with a mix of that microfibrillated material and TIFA fibre, actually just because of its material properties. It doesn't need any sort of chemical filler. It's in his words, it's a wonder product. Joanne's heard him talk, and he can talk for a very long time and get very excited about it. So I think it's that connection, I think, that just might be quite interesting. They're very interested in replacing particularly mineral fillers and glues and gums in boards, because they see those as carrying quite a big carbon footprint forward into the boards. But I think there's just some interesting links that we might make, and I think this is why we wanted to have the workshop, between work that is happening with TIFA and wetland hay and reed and others, and actually the products that are coming from what I might call dryland situations. So Miscantha sits somewhere in the middle there too, so also interests around there. So I think there really are some interesting potential overlapping conversations in this space.
Yeah, brilliant. I've been bring it on. I'd love to work with you on that.
Thank you. Right, Jasmine, have we got anything else in the conversation that I have missed in the chat?
Not that I can see.
Okay. If not, I think we've had a lot of questions and discussion. So thank you very much, everybody, for putting those questions in the chat. I see there's a number of conversations that they will continue beyond the end of the workshop, which is, sorry, the webinar, which is exactly what we want to see. So I think it just probably remains me just to thank all of our speakers for today, for their presentations, for sharing their thoughts on how we can collectively, hopefully, move the opportunities for biomaterials for construction forward, how we can overcome some of the challenges, the investment challenges, the certification challenges, and the sort of the practical challenges of getting these crops grown out there. So yes, so please do stay in touch with the two projects, the Paludiculture Exploration Fund and also CHCX3. We will be carrying on with the project right way through till 2027, and we will be doing much more work to hopefully both develop the crops, that some of the crops we talked about, including hemp, but also develop obviously the use of those materials through to the products. So yeah, keep in touch with our website and our other free events and webinars, and hopefully we can carry on the discussions that have gone on today. So thank you very much, everybody, for your participation, and we look forward to welcoming you to a webinar again soon.
Thank you very much.
Thank you.
Cheers.
Thank you.
Thank you, everyone.